Welcome, Swagatam in my computer learning series, that is learning computer with seeing the beautiful, attractive, nice, even like sites of Bhartiya village or gaon. Village is in Hindi it is called gaon. So then in this Bhartiya gaon, uh, you are viewing the even like natural sites of greenery sites of this gaon. Now in the previous lecture we talk about the preprocessors directory. Let's see again it. The preprocessor is a program that does some preparation for C compiler before compilation of a program. Consider the library function clear a screen parenthesis scanf parenthesis and printf parenthesis. These are library functions for input and output. Every C compiler provides many such useful library functions that programmers can use directly in their programs. Compilers group the library function in different categories and store them in different files. For example, library function for input output are stored in stdio.h file, and similarly library function for string handling are stored in string.h file. So to use one or more library function from a standard file of a library function in a program, the code of that function should be included in the program so that the compiler generates the object code for the instruction in the library function as well. To enable this, C provides has include preprocessor directives that tells the C preprocessor to look for a file and place the contents of the file in that location of the program where has include directive is used. For example, has include a space open angle bracket stdio.h close bracket is required in a program if a standard input output library functions are used in the program. Next, has include a space open angle bracket string.h close angle bracket, and it is required in a program if a string library functions are used in the program. Other C preprocessors directives used commonly in C programs are has defined and has if def. Has define is used for macro expansion and has if def is used for conditional compilation of segment of a program. Now see illustrated from example. For example, has defined a space cap pi a space 3.1415 a space solidus asterisk will substitute the value 3.1415 where cap pi is used in program asterisk solidus. Next, has defined a space cap and a space uh, symbolic and. Next line has defined a space or cap or a space symbolic or solidus enables use of cap and cap or instead of logical operators symbolic and symbolic or respectively as in the if statement given below. If open parenthesis a is less than 4 close parenthesis a space cap and a space open parenthesis b equals 25 cap of a space y less than equal to 65 close parenthesis instead of if open parenthesis a less than 4 close parenthesis a space symbolic and a space open parenthesis b less than equal to 25 symbolic or y less than equal to 65 close parenthesis close parenthesis. Now has defined cap admit printf open parenthesis open quote the candidate can be admitted close quote close parenthesis semicolon. Next has defined cap fail a space printf a space open parenthesis open quote the candidate cannot be admitted close quote close parenthesis semicolon. Next line if o a space open parenthesis marks greater than 60 close parenthesis. Next line cap admit. Next line else. Next line cap fail. Next line if marks is more than 60 comma this would display the candidate can be admitted. Next line else would display the candidate cannot be admitted. Next line has defined cap square open parenthesis n close parenthesis a space n asterisk n Solidas asterisk will substitute the value of n asterisk n wherever a square is cap square is used in program asterisk Solidas. Has if def a space cap windows vertically 3 dot code specific to Windows operating system vertically 3 dot has is vertically 3 dot code specific to Linux operating system vertically 3 dot has end if vertically 3 dot code common to both operating systems. If we want to run a program on Windows platform, we have to add just a statement in the beginning saying has defined a space cap windows. The compiler will then compile only the code specific to Windows operating system because of the use of has if def cap windows preprocessor directives in the program. So we see some standard preprocessor directives with their meanings here. Now we see it with category wise. Now the first category is simple and preprocessor directives is has, its meaning is null directive. And next is has error message, its meaning is that prints message when processed. Next preprocessor directive is has line num file name, used to update code line number and file name. And next is has pragma name, used for compiling a specific settings. So these four are simple categories preprocessor directives. Now we see some conditional preprocessive directive, that is category is conditional. For example, has if expr includes following line if expr is true. Next is has elif expr includes following lines if expr is true. Next is has else handles otherwise condition of has if. Next is has end if close has if or has elif block. Next is has if def macro means includes following lines if macro is defined. Next is has if def macro if def macro includes following lines if macro is defined, and next is has if n def I macro includes following lines if macro is not defined. So these are some conditional pre-processive directives. Now we see some operators directives, that is categories operators. For example, has a string forming operator, double hash, that is has token passing operator, and defined same as a has if diff. Next we see precursor directives. Has include file name, this category is file, include content of another file, and has defined macro slash string, define a macro or a string substitution, its category is macro, and has on def macro removes a macro definition, category is macro. So these are some standard preprocessors directives used in C language. Now we see the next term use of C programming language is pointers, array, and strings. So let's see it one by one. C pointers allow programmers to directly access memory address where variables are stored. That is, a pointer data type is a specific modifier of any other data type that has a variable name and a storage associated with it. A pointer to a variable is declared by adding a asterisk symbol before the variable name while declaring it. For example, int a space asterisk p semicolon. This declaration tells compiler that p is a pointer variable for an integer. The program will use it to store the address of an integer variable. In other words, p point to an integer. Using asterisk p means the value stored in the storage location pointed to by p. Using p means the address of the storage location. In C, and symbol is used with a variable to mean its address. Here, if I is an integer variable having current value 62 and address 1000, and I would return 1000 and simply I would return 62. Pointers being an address type have interesting possibility of being part of arithmetic operations like addition and subtraction. Adding or subtracting a number from a pointer results in another address. For example, p plus plus will result in address of p pointer variable to be advanced to the size of its data type. Consider that p originally has address 1000 and is a pointer of int data type, then p superscript plus plus will now result in p getting address 1002 due to int data type being 2 bytes or 16-bit long. It is possible to declare double, triple or more in direction pointers by using asterisk as many times. Hence we use asterisk asterisk for double pointer and asterisk asterisk for triple pointer. Okay. Now arrays. An array is a collection of elements in which all elements are of the same data type. It is a homogeneous, linear and contiguous memory structure. Consider an example. We can have any array of int, float or char data types. An array has a fixed number of elements called its length or size given at the time of its declaration. The size parameter must be a numeric, literal, or constant. We can refer to elements of an array by using their subscript or index position that is monotonic in nature. The first element of an array is always denoted by subscript value of 0, increasingly monotonically up to 1 less than declared size of array. While referring to an array element, we can use an integer variable as subscript instead of constant. Such constant. This ability to use variables to represent subscript is what makes arrays so useful. Array variable name is an address type data variable, and hence just using the name of the array variable refers to its start address or the address of 0th element. So before using an array, we must declare its type and dimension. However big an array, its elements are always stored in a contiguous memory location. For example, int space marks open bracket 6 close bracket semicolon solidus asterisk an array of integers having 6 element asterisk solidus. Next, float a space price open bracket 4 close bracket semicolon an array of real numbers having 4 elements. Next, char a space ct open bracket 6 close bracket semicolon an array of characters having 6 elements. So apart from knowing that any variable is an address, data type, or a pointer, we need to understand that we cannot change the address of an array variable. Hence, an array variable has a constant address. However, since we can use a pointer in arithmetic, asterisk marks is same as marks open bracket 0 close bracket asterisk open parenthesis marks plus 1 close parenthesis is same as marks open bracket 1 close bracket, and so on. We can also declare an array as a multiple dimensional. For example, int space matrix 2 cap d open bracket 10 close bracket space open bracket 10 close bracket semicolon defines a two-dimensional matrix of 10 into 10 rows and 10 columns. It is a two-dimensional array of int data type and its size is 10 into 10, that is 100 elements. The array elements can be accessed using matrix 2 cap d open bracket 0 close bracket open bracket 0 close bracket matrix 2d open bracket 0 close bracket open bracket 1 close bracket matrix 2d open bracket 0 close bracket open bracket 2 close bracket, and so until matrix 2d open bracket 0 close bracket open bracket 9 close bracket, which is the last element position in the first row. Now the second row can be accessed using matrix 2d open bracket 1 close bracket open bracket 0 close bracket matrix 2d open bracket 1 close bracket open bracket 1 close bracket matrix 2d open bracket 1 close bracket open bracket 2 close bracket, and so on until matrix 2d open bracket 9 close bracket, which is the last element position in the second row. Similarly, the last element in the array will be matrix 2d. Now strings. An array of character is called a string. More precisely, a string is a one-dimensional array of characters terminated by a null character, that is /n. We can initialize a string as char space name open bracket space close bracket space equal space uh, open quote Kardeep close quote semicolon. Note that we do not specify the null character in this declaration because C inserts it automatically. Obviously, we can access the individual elements of a string in the same way as we access array element. Hence, name open bracket 0 close bracket equals to P. Name open bracket 1 close bracket equals to R. Name open bracket 6 close bracket equal to P. Programmers use strings for text, that is words, sentence, etc. pre-processing. To make the job of a programmer simpler, all C compilers provide a rich set of string handling library function. So with this I would like to end this lecture here, and in next lecture we will see some user defined data types.